All right, I apologize today that I have a little bit of a cold, so my voice is off, but we carry on. And so let's talk about DHCP, Dynamic Host Configuration Protocol. One of the main things I'd like to get out of this today is just focusing on what are the four steps that occur with the acronym DORA related to DHCP and what do they mean. Now, in the context of our data communications course, we've been covering some lower level things related to the OSI model in previous weeks. And for the remainder of our course, we're going to be talking about applications that run at this upper layer that depend on the lower level data communications protocols and layers functioning properly. One point of emphasis that might be nice, though, is to leverage this slide that I grabbed off the web. And that is the point that we have two applications that communicate, and they communicate back from one to another if we have host 1 and host 2 using data. But in order for that to happen across a network, starting down here at the transport layer, we wrap that data almost as if it were in an envelope. We add in some transport information such as source ports and destination ports. We then take that, if it were a letter with data in it, and put that letter in another letter called a packet, and that packet then has IP addressing information, and then as needed to send it across a local area network, we put it within a frame for Ethernet, and we put it yet again in another envelope, and then we transfer it and turn it into ones and zeros. It gets transferred then across a wire, where then we start unpacking that envelope. The Ethernet layer can then again be used to determine which physical devices something is going to be delivered to, and then anyway, iteratively it can start taking off other layers until of the envelope until we get back to the data again, and then it's ready to be used by an application. Also in this course, this begins the time when we're talking about the application layer. And I'll note that if you talk about the application layer online, for example, there's a guy, Eli the Computer Guy, who's pretty famous and he's got some good videos. He'll characterize the application layer as being a program like Firefox. And I think that's okay for a data communications class to say it is the application and whatever protocols it uses to communicate back and forth. And so we'll pretend that that's true. However, I'll highlight this definition here that says determines the identity and availability of communication partners for an application with data to transmit. Or I put a subtle distinction comment down here. The application layer is really about technology that interacts with the software application, and it isn't actually the application itself. It's a subtle enough distinction, and it's not really important in our class, so we'll just pretend like the application level really and layer really is the applications that communicate one to another and whatever protocols they use. But technically it's a little bit lower level than that, but close enough for our purposes. I'd like you to take a moment to go over to Wikipedia, type in application layer, and on the sidebar, you'll see how the application layer technologies are defined differently depending on if you're talking about the TCPIP or DoD model compared to the OSI model. Of course, the OSI model, it's more granular in terms of the application layer definition, and with the TCPIP model, it's more inclusive of several technologies, but I wanted you to see the list of technologies that are listed there as part of the TCPIP list of applications, because that includes many of the things that we'll be covering for the remainder of our course. And here are some examples of things that you would see in that list, things like web servers, mail servers, DHCP, and DNS. All right, let's jump right into DHCP, Dynamic Host Configuration Protocol. I think there's a pretty good graphic over here that we'll return to in just a minute, which really captures the main idea. And after we talk about many of the ideas related to Dynamic Host Configuration Protocol, even though it gets a little bit detailed, at the end of the day, this is the high-level picture in your mind that you should walk away with. Okay, if you've been working with computers very much, then you'll have seen settings areas for your adapter, for your network adapter, that look like this. If you're setting them permanently the IP addresses associated on those devices. You'll set them like this with an IP address, subnet mask, default gateway, preferred DNS server, alternative, etc. And then here's some comparable things that you would enter in if you were on a Mac. But if you've been doing that manually for purposes of a lab, for example, wouldn't it be nice if you could auto-magically get all that information, have it delivered to your computer, an IP address, a subnet mask, default gateway, etc. It'd almost be like a Christmas gift if it could show up that way. Now, we do want to typically have a static IP address if we're setting up something like a server that we don't want it to ever change its IP address in our network. However, if we're just using our consumer devices, a computer that walks into a room, a mobile phone that's in a room at a McDonald's, then we don't really need these things given to us permanently or set statically. What we do want, it would be nice if we could just get it temporarily and not have to worry about the administrative overhead for it. So speaking of administrative overhead related to DHCP, got a little picture of Homer here going, dope, representing the idea that if you are setting things yourself related to one of these pictures here, these figures, there's a good chance that you're going to make errors. You'll type in things incorrectly, and that's just part of human nature anywhere where humans do data entry. And so because we don't want to do that whenever possible, we allow software to configure the IP addresses and the subnet masks and tell the computer what its default gateway and DNS servers are going to be. And to do so, it goes through this process, and I'm going to walk through it here. So imagine that you are a client computer and you are coming onto a network and you need an IP address. What you do is you send out a broadcast message saying, hey, can anybody on this network give me an IP address? And a DHCP server is running, and it has a table of available IP addresses that have not been loaned out, and it sends out to the entire network an offer. Hey, whoever that was that just asked me for an IP address, if you're out there, here's an IP address that's available to you. And so then this computer says, okay, again, broadcast to the whole network. Wherever you are out there, I would like to request that IP address that you just gave me, that you just offered to me. The computer then makes an entry. It says, okay, this hardware address that I just saw, this MAC address that was sent in the request is now going to be associated with a particular IP address that it just requested, and I will send back an acknowledgement. Now, it's the high-level thing that you need to understand, but I'm going to go a little bit deeper just so you understand it. So it's technically a client-server model where you have clients of DHCP that request their IP addresses from a DHCP server, and a DHCP server has a database of IP addresses that it can loan out. Now, these IP addresses, sort of like the inflatables at a water park, are in limited supply typically, and so it is possible to exhaust the available ones that are there, and then you have to wait until a computer's lease on an IP address expires for you to get one. If you are looking in DHCP software in Windows, you might see something that looks like this, a list of IP addresses that have been assigned out and the name of the computer that got that particular IP address. In addition, you might also see how long that computer is going to have a reservation on that IP address, as well as the MAC address associated with this particular computer. Now, to go into even further detail for a moment, here's the overall process. We have a local computer that says, hey, I'm going to talk to the whole network. So it's sending to the broadcast address of FFF, all Fs, and basically it's requesting, can I have an IP address? The server heard that broadcast and it says, I'm going to offer you this address right here that ends in .51, and it broadcasts out to the whole network. Again, the destination address is everybody. Then this client computer, having heard that, says, I would like to formally request that IP address that you just gave me, and it's going to tell it, what your MAC address is as well. And and then in the computer over here at the server, it's then going to create an entry in its database with the MAC address and the IP address associated with it now, and then again broadcast out to the whole network. Okay, that in essence it's going to contain the information that says that MAC address is going to be associated with that IP address, just letting everybody know. And I have a little question here. Why do we do that? This is kind of a weird sequence of steps. And one of the reasons for this four-step process is that it's possible for redundancy purposes that we would have multiple DHCP servers on our network. And so if a request goes out from a client and multiple DHCP servers respond, the request should only be with respect to one of those servers that offered it something. All right, so I think it would be a fun little game for you to play for a moment to turn to one another or somebody else, or even yourself, I guess, and talk about how DHCP works according to what you just learned, and role play for a second. Have one person play the client and the other person play the server, and think of IP address ranges that are legal in a local area network environment, and then make up the conversation that would happen as you go back and forth. Okay, having done that, pause if you need to, but I'm going to move on. Just some additional information about DHCP. It formally uses port 67 and 68 for it to run on a network, and the protocol associated with its communication is bootp. Okay, and so once again, the lease process can be remembered using the acronym DORA. And so make sure you have that memorized. That's one of the main ideas to take away from here. Okay, so this is an interface that you would find in some way, shape, or form on any device that gives out IP addresses. And in this particular one, let's look at the interface in the lower portion. So again, this interface could show up in a Google Fiber router device at home, or any local router device that you would buy from a place like Walmart. When you go into this configuration settings, you're going to see something like this. And so I'm going to just jump through some things here. One of the things that jumps out to me is for LAN IP address, we've selected either an A, B, or C address range and a subnet mask associated with that. So we're saying this is the address that we're going to use for our local area network, everybody that connects to me, and this is how we're going to subdivide it depending on how many hosts we need or how many networks we need. Next item is enable DHCP server, meaning am I going to have a range or a database of IP addresses that are within a particular network space that I'm going to be able to lease out. And so you select yes if you want that to happen dynamically. And then over here we can see for each IP address that's leased out, how long can it be leased out for, and you can range this based on what the needs are. If it's a little restaurant and people are, or Taco Bell and people are there for 20 minutes and then gone, then a short time period is sufficient. If this is something like your home, then maybe 2 weeks is fine for a lease time. Over here, next line says the starting IP address. Here it goes. It starts at 2, and it's saying, hey, we're going to give out 50 of these. So this implies then that you're going to have anyway, starting from the number 2, add 50. That's how many addresses you're going to be able to have that are dynamic for your network. So this would probably be for like a home router. And then down here we have a static section. So well, wait a minute, would we actually have dynamic IP addresses and static ones in the same network? Sure. What typically you do is within a given range, like so from .1 up here all the way up to .254, you might reserve a block for dynamic allocation and another block that's going to be static and not leased out. And why would you do that? Well, some of the devices in your network, if this is a small office environment, you might want associated with a printer, and so you want a MAC address associated with a particular IP address, and you want that never to change. Another thing is maybe you have a server there in your office and you want it to always have the same IP address, even though there are floating addresses that are there for devices coming in and out of the room. Okay, so what happens if a DHCP server does not respond on the network? Then you'll oftentimes see an address that starts with 169, and that means it's auto-configured and given itself an address, but you're not going to be able to browse the internet with that, so it's not the greatest thing in the world. But another thing that people oftentimes are curious about is like, okay, how does renewal work? What happens when you're running out of your lease and if it's 24 hours, for example? Well, the renewal process is such that a client will halfway before its lease is over will reach out and try and renew. So if you had a 24-hour lease, then after 12 hours it's going to jump out and try and grab a new one. And if it can't reach the DHCP server, this happens in our lab. Sometimes we have power outages, and might be a couple of weeks, as I say that softly, before we realize that the DHCP server is down, and so computers start dropping off of the internet because they don't have IP addresses anymore because the time runs out. The last item here says, when your time runs out, you try and request a new one, and anyway, so they're off the internet after a while. But and basically, they just keep on having the time in their request to renew a lease if they don't get a response. So you go from, if it's going to die in 24 hours, you request in 12 for a renewal. If you don't get a response, you request 6 hours later. If you don't get a response, you request 3 hours later. Something that you may do if you are changing IP configuration settings, either on your network or your local computer, is you might regularly release or renew the IP addresses. And so oftentimes you'll type in ipconfig, release and renew, in order to facilitate that type of thing. On a Mac, there are several different commands for renewing your IP settings. And that terminates and ends the discussion I had today for DHCP.